All right, looks like Jared already started the recording, so I'll start with the Tennyson notice. The MnDOT Bridge Inventory Management Unit believes recording this session is the most beneficial way to provide information to MnDOT and local employees as a learning resource. It will be posted on the MnDOT Bridge Inventory and Inspection website. Your image, which may be private data, might be captured during this event. You're not required to allow MnDOT to use your image. There's no consequences for declining. The recording is accessible to anyone who has a business or legal right to access it. By participating, you are authorizing the data collected during this recording to be maintained by MnDOT. This will be our only SNBI component condition appraisal and roadside hardware items training this year. Please contact us to go over your questions if joining this recorded session is an issue. So to opt out of the recording, please exit now. Otherwise, I will turn it over to Pete Wilson and we'll start the training. Thanks.
Okay. Thanks for logging on for this meeting. Sorry, I had a little problem with the mute button there. Anyway, my name is Pete Wilson. I'm with the Bridge Office Inventory Unit. This presentation is pretty much a repeat of several topics we covered at the refresher training earlier this year. We'll cover the SNBI component condition ratings, the SNBI appraisal ratings, and the SNBI roadside hardware items. We are going to run through some coding examples, including some test questions from the refresher training. If you did attend the training earlier this year, you should have a copy of the 2025 Bridge Inspection Field Manual and the report entry guide. Those are the two manuals you see there. Those should be helpful as we go through some examples later in the training. In the email Joe Rosella sent out, he included some links to where these are, and I think he also put them in the chat. So if you do need to look those up, those are there. So starting with the SNBI component condition ratings, obviously that's the big change this year as far as a bridge inspection. We're going to be retaining the 5 original MBI ratings we've been using since the 70s, but there will be some revisions to those, and we'll go over those. In addition to those, with this year with the SNBI, there are now 6 new items that have to be rated during routine inspections. So obviously a lot more work, and these are going to come in, without any. They won't have a initial rating, but some of them will have some notes in there, so you can use those hopefully to help you rate those items. In addition to those 6, there are these other 2 items. These items are not included in our manual. They're calculated automatically, and they'll be displayed on the inventory and inspection reports. Essentially what they're doing, this is to replace an old item that was called the structurally deficient that was in the old system. They did away with that term, and suddenly that's been replaced by just a good, fair, poor designation. And again, that'll be displayed right on the top of your inventory inspection reports, and it's going to be based on the lowest of the main SNBI ratings, the deck, super, sub, or culvert. And then the final items are what we call the NSTM, used to be fracture critical, and the underwater inspection condition ratings. These are included in the inspection manual, but they're not going to be rated during routine inspections. They're only done during those in-depth inspections, and those are essentially set up to establish the frequency for those inspections. Now, if you have a bridge inspection manual on page B8, there's sort of a general table for the SNBI component ratings. One of the reasons the Federal Highway kind of revised these, they really wanted these component ratings to correlate better with the element condition ratings we've been using since the 90s. And so they adopted sort of a 4-level defect system that they took directly from the AASHTO manual for bridge element inspection. One of the changes with that, instead of using the condition state numbers, they decided to name each defect level. So this kind of show how they relate, but anyway, the first ones are the inherent defects, and those correlate with condition state 1, and some examples would include, say, shrinkage crack in concrete or a rolling defect on a steel member. The next one up would be minor defects, and those correlate with condition state 2 of the elements. And that's when deterioration is initiated but is not yet significant. Examples might include light leaching cracks in concrete, surface corrosion in steel, surface checks in timber. Moving on from that is the moderate defects, and those correlate with condition state 3 in the element system. That would be a defect that is more significant than minor, but the strength of the component is not yet reduced. Some examples include, like, say, spalling with exposed rebar in concrete, flaking rust on steel, or decay in timber. And then finally, of course, we have the serious defects, which correlate with the condition state 4 defects in the element system. And that would include, say, severe section loss at a steel beam or crushing of a timber pile. In addition to that, if you also see on page B8, we also have some terminology they use to describe the extent of those defects, and that is either isolated, some, or widespread. These are obviously pretty subjective terms, and they don't define them really well in the SNBI. What they do say is that they say that a defect is considered widespread when it is present in many separate areas, where an isolated defect would be in only one or a few locations. And then the word some is just whenever it's more than isolated and less than widespread. So again, pretty subjective and vague, but that's what they use in this table. Anyway, if you ever looked at this SNBI manual, the component rating guidance is spread out in 20 tables over about 47 pages. We decided that was not very a great way to use in the field. So what we've done is we've merged that SNBI guidance into a one-page table for each item, and kind of use the same format we've been using for several years here in our manuals. And so instead of having those 47 pages, we've knocked that down to 15 pages. The SNBI they copied those defect tables right from the AASHTO manual. And so like AASHTO, there's very detailed guidance for minor and moderate defects, the condition states 2 and 3, but very minimal guidance for inherent or major defects. So that's one thing we tried to expand a little bit, tried to give a little bit more definition of those, what's, inherent and major, but we can't describe every possible defect in a one-page table. They're not perfect. So we do appreciate any feedback we can get to improve these. We'll probably be putting out another field manual in 2 years. So, as you use this, try to give us some feedback. If we don't hear from you, we'll never be able to fix it. Another one big change to the table this year is for condition state 9. That used to be just for new condition. Now it's changed to that component has not been assessed. So that's kind of our when we enter in for new bridge or for these new items as they come in. And so after you look at it, if there's not an issue, you're supposed to move those to an 8. If you've already done some entry work in SIMS, you'll realize that there's a system that will catch those, and so they won't allow you to submit that report until you change those all to a condition state 8 or lower. Now I want to go over some of the revisions, starting with the deck condition item. The SNBI the big change to this one is that in the SNBI, the deck rating does not consider the condition of non-integral wearing surfaces. That would include, say, a low slump overlay, bituminous overlay, epoxy chip seal. In our state, we've always considered that wearing surface in the condition rating. It's always been a primary consideration for rehabilitation projects, so it's not a change we liked. But just be aware of that. Also, since the SNBI doesn't have an overlay item, our wearing surface element 515 is really the only way to track the condition of overlays now. For decks, bare concrete decks or decks poured to finish grade, say without an overlay, that top surface condition is considered. So that does make for some confusion. There are 2 different ways you can rate these, and we have nearly 7,000 bridges with concrete decks or slabs, and so that means half of them are going to be rated one way, just by the underside, where the other half are going to be rated using both the top and bottom, depending on how those are constructed. Now here we're going to start doing some examples. if you want to, as we go through these, we don't really have a great way to respond, but if you did want to say, if you came up with your rating, you could add it into the chat, and then at least Jared could see it there. But anyway, this is actually the first test question that we used for our fresher training. In this, we described the deck condition using the same language as the table on page B9. And I really thought this would be an easy question, but people had a really hard time with this one. So I kind of want to run through it. So this is the way we described it. Again, we got a low slump overlay, good condition. Underside has widespread loose to nail lamination and spalling. They mentioned, that any significant section loss at steel enforcement is isolated, and the structural capacity of the deck has not been seriously affected. Now, here's the table that we have for this. In this case, I just included condition states 3 through 6 to otherwise it get too small in here, and I kind of limited it to the concrete defects. But if you look at this, just consider, how do you think this deck should be rated? First off, this new rating does not consider the overlay condition, so we can kind of disregard the condition overlay. We're only looking at the underside for a deck because that's a low slump overlay, so it's non-integral. Also, since the structural capacity is not seriously reduced, we can eliminate condition state 3. So that leaves condition states 4, 5, and 6 that we want to look at here. The way we do it, spalling with exposed rebar, loose laminations, those are considered to be moderate defects, both in our our element rating tables and in this one. Whereas a deep spall or exposed reinforcement with significant section loss, those are major defects. And the way this was described, the deck has widespread moderate defects and isolated major defects. So based on that, which one of these is the best fit? And the way we looked at it is this lines really well with a 4. We and again, we use the language right out of the manual to go with that. During our fresher training, only 58% of the people rated this a 4, which I thought was pretty low. We do give partial, we give a kind of a tolerance. We give partial credit for condition states 3 or 5, but we had about 28% of the people rate this deck as a condition state 6, satisfactory, which we thought was way too high, and they received no credit. And so I'm not quite sure what our problem was there. It was the wording of the question, the wording in our manual. Maybe the overlay had some bearing on it, but it's one that I was surprised we had that many people answered that differently than what we expected. Moving on, we'll just talk about the superstructure. There are a couple revisions to this that might cause like a previous rating go up or down one level. It'll be a lot easier if you have good notes explaining your MBI condition ratings. Under the SNBI condition state 7 is no section loss on primary steel members. In our old system, we could get by I think minor section loss was a 7. So we are going to have some bridges that are going to drop from a 7 to a 6 just due to the isolated minor section loss. Hard to find a steel bridge out there that doesn't have some minor section loss on it. So that might have some impact. Also, shear cracking. In our old manual, we had structural cracks may be present as condition state 5. That was based on the old coding guide that the first mention of cracking was down to condition state 5. So we felt we couldn't do it higher than that. But in this new system, in the new SNBI, we can allow some higher ratings for shear cracks if it's isolated or minor. So that is a change there. So if some of you, if you had moved it down, you could move that back up if that's just isolated. And the other change is for bearings. Those are now rated under a separate SNBI item. So for bearings, if you did have a superstructure that was marked down due to bearing issues that didn't impact the rest of the superstructure, you could raise that rating up. And so this is another example here. This is a question from the refresher test. And again, we described using the same verbiage right out of the table. So, we hope most people get this right. Kind of described that you see on the left there of the screen with the flaking rust along the bottom flange, significant section loss in some critical stress areas. We did make the note that the structural capacity is slightly reduced, but not seriously affected. So looking at the table, we just included, in this case, I'm just showing condition states 3 through 6 from page B10. What would you rate that? There are a couple ways of looking at it. First off, looking at the defects. Flaking rust indicates that some section loss. Section loss is a moderate defect. So in this case, the superstructure has widespread moderate defects with significant section loss in some critical stress areas. So looking at that, condition state 4 probably fits that the best. We also said in here that the structural capacity is slightly reduced but not seriously affected. And that kind of rules out condition states 5, which is strength and performance are not affected. And whereas condition state 3 also would be eliminated because that's this, the performance is seriously affected. So that again, using both criteria, it would end up with a condition state 4 for the rating. And in our test, 90% of the people did have that rated 4, which is good. That's pretty good. But I think we had 5% rated a condition state 6 satisfactory and got no credit. So that was a little disappointing. I think people should have been a little closer on that one. Moving on to the substructure. The main revision to this is related to shear flexure again, where we've made that same change that we did for superstructure. Our old guidance, structural cracking is pretty common on concrete pier caps, and with our old guidance, we had a lot of bridges that were rated down to condition 5 due to shear cracking in those caps. While this is a concern, there are instances where, if that's minor or isolated, we felt that condition state 5 would be too low, so you could raise that up in those situations. And here's a rating example, again, based from our refresher test that we had. In this case, we had just a simple statement in there that we had some isolated lamination and spalling with exposed reinforcement. So looking at the guidance on page B11 in the manual, here's for substructure, and I just shows, again, condition states 4, 5, 6, and 7, what we rate there. First off, condition state 7 says no exposed rebar. We had some exposed rebar, so we could kind of rule that one out. Spalling is considered to be a moderate defect. This spalling we said was isolated, so for sure we can get rid of the poor condition since it's not widespread. So we're down to the other two options, which are widespread minor, isolated moderate defects, or some moderate defects. And yeah, again, it's very subjective terms. Some are isolated, but in this case, we said right out there that it's isolated. So the answer in this case should have been a 6. We had about 77% of inspectors rated this condition 6, but we did have some people rate this in condition state 4 and get no credit. And, isolated spalling, I don't think that should be knocked down to a 4 for poor condition. Moving on to the culvert condition rating. This table is worded differently than the old table in our system, but they're close enough that migrated rating should not need much adjustment, if any. And I also want to point out, in this, that these SNBI defects correlate really straight on with the element level defects. So if you, for instance, for a concrete culvert, the defect the descriptions in the SNBI table on page 12 are going to correlate with the element ratings. And that's, I think, on page B180. So, for instance, light leaching is a minor defect. Heavy leaching is a moderate defect. Also for spalling, a small spall without exposed rebar, shallow spall, is going to be a minor defect. Spalling with exposed rebar is going to put you up to moderate. And if that spall is deeper than 4 inches or the rebar has severe section loss, that's going to be categorized as a severe defect. So here's a coating, a rating example of a culvert. This is a cast in place box culvert with heavy leaching cracks throughout the walls and ceiling. In this case, this culvert also has spalling with exposed rebar and also has some scattered areas of rust staining and joint separation in the wall between the culverts. And when we're rating one of these SNBI condition items, you need to identify both the severity and extent of any defects present. Heavy leaching cracks are condition state 3 for elements, and a moderate defect for SNBI ratings. Depending on the severity, spalling and joint separation could be, considered to be a moderate or a major defect. And just a reminder that, when you rate, you've already rated, for instance, this culvert, you've already gone through and rated the concrete culvert element, and those should really already describe the extent and severity of these defects. So, if we pull up the current culvert ratings for this is the culvert element ratings. As you can see, we have probably about 81% rated as CS2. That's a minor defect. We got about 17% rated condition state 3, moderate defects, and a small amount, about 2% rated CS4, major defects. And in the element notes, it explains that the 6 linear feet of condition state 4 is due to spalling at joints that are deeper than 4 inches. So as we apply those to the culvert component rating on page B12, we can run through and kind of look at how those are rated. So first off, looking at the defects, based on those element ratings, we're going to have some widespread minor defects, some moderate defects, and isolated major defects. And looking at the tables, none of these are a perfect match. But since condition states 5 and 6 say no major defects, condition state 4 is probably the best answer there as far as how to rate this culvert. Again, that's based on the defects. Keep in mind that these tables do have other criteria just beyond the defects. One of those is strength and performance. And so again, based on the defects, 4 is the best answer there. But we also have another way of looking at another criteria here, and that's strength and performance. And this is why it can be kind of subjective. In this case, for condition state 5 says that strength and performance are not affected. Condition state 4 says strength or performance is affected. And in the case of this specific culvert, they had actually gone, and we had the same issue with the older tables that we used prior to this. They had kind of the same criteria as well. They have these different criteria, but they don't really say which one should govern. And so, lowering an MBR rating from a 5 to a 4, it has a lot of impacts on your BPI, LPI, the inspection interval, things like that. So, people are kind of hesitant sometimes to drop something from a 5 to a 4, or they maybe want to raise it from a 4 to a 5. In this case, this bridge was, the inspectors back in 2019 lowered this culvert rating to a condition state 4. And then during the subsequent inspection 2 years later, the PA reviewed it and determined that the structural capacity of the culvert was not reduced. And in that case, they decided to raise it up to a 5 the following inspection. And that is one of the reasons we do allow a tolerance of plus or minus 1 for component ratings. So there is some subjectivity to it. Just to point out that in the proposed metrics, the federal highway, they're saying they're not going to allow any tolerance between conditions 4 and 5. And I think that's totally unrealistic. But it's also why it's important to have really good notes to explain your component ratings, especially when they start to get lower down in the system. In the case of this culvert, they had excellent notes to explain why they'd adjust that rating up from a 4 to a 5. And in this case, I would say that either of those, depending on which you use, would be correct, 4 or 5. And that's again why we have that tolerance we allow. Now we're going to move on to the new SNBI item, starting with the rail condition item. Again, being that this is a new item, the initial rating is going to come in either as a 9 or an N. If you have no problems with your railing, it's perfect condition, move it to an 8 after the inspection. A few things about this item. First off, this only needs to be rated for vehicular railings. This is our example we gave at the seminar. The Stone Arch Bridge has maybe a mile or so of steel railings. We rate them under the steel element, but as far as this component thing, it's just going to be entered in as N since this is classified as a pedestrian bridge. If you have a railing like this, where there's sort of a concrete barrier with a steel railing mounted at the top, where the steel railing is really more for pedestrians, since those are integral and tied together, you would consider the damage to that upper railing in this rating. You do not consider the condition of protective coatings. Just corrosion can mark it down, but just fading or chalking or peeling of a paint layer or galvanized is not going to impact that rating. And this does not impact your inspection intervals. So if it does get dropped down really low, it's not going to force you into a 12-month inspection 12-month inspection interval. So here's kind of a rating. This is actually from Scott Tyson's presentation at the training this year. This bridge has its original railings from back from 1966. This is what we call our MnDOT rail type 14. It's a one-line concrete base that has a two-line upper steel pipe. There's also a tension cable that runs kind of below the horizontal concrete there that goes through the rail posts that ties everything together. Keep in mind that this new coding item doesn't have any sort of migrated railing or notes, but the railing condition has always been documented and rated under the railing element, so you can look at your notes and your ratings for that element when you're rating this item. You can help ballpark you in or get it in there. There wasn't a way for us to do this automatically because it was just too messy with the multiple elements you might have, but you can at least take a look at those. Combination railings, they're rated under more than one rail element. In this case, it's concrete and steel, so you have a concrete element, and these are the concrete ratings. We can see we're mainly condition state 2 with about 10% at a condition state 3, with nothing rated condition state 4. The steel portions of the railing in this are better shape, and this is the current element ratings for the steel element, mainly condition state 1 with a little condition state 2. Based on the on those element ratings, you could say that we got some moderate defects with a condition state 3. So because of that, if you look at the SNBI rating, I think if you have moderate defects, it has to be rated condition state 6 or lower because of those moderate defects. So as we go through the rating here, we'll only look at 6 or less when I get there. But anyway, here's some photos of the railing. The upper pipes have some fading the galvanized coating, but we don't consider that in this rating. We're only concerned about corrosion or section loss. And you can see there's some surface corrosion maybe down at these connections, but nothing really significant. The lower tension cable has some coating failure and surface corrosion, but again, no serious, nothing that would rate it down to a 3 or lower. The concrete posts and beams have some map cracking, rust stains, spalls with the exposed reinforcement. In this case, it's kind of a subjective thing, but we said that, the spalling is not severe and does not yet impact the strength of the railing. So looking at our condition states 4, 5, and 6, here are the kind of the codes that come from page B13. We have no major defect on this railing, and the strength of the railing has not been reduced. So that probably is going to rule out condition state 4, but we still kind of need to look at the extent of those moderate defects. So looking at those, on this railing, we have condition state 6 is isolated, 5 is moderate, is moderate defects, and then 4 is a widespread moderate defects. And this concrete railing had about 10% rated 3 due to spalling and other defects. I would not consider that necessarily to be widespread, but I think it's more than isolated. So Scott and I both thought that based on that, a condition state 5 was probably the appropriate rating for this railing. Another new item that we have this year is the railing transition ratings. This is a brand new item. We've never had rated under an element or anything else before. On a typical bridge, this will include the end post and about 20 to 25 feet of guardrail at all 4 corners. In this case, it's kind of hard to tell where it stops. It's going to, in this case, it's going to go probably to the end of that approach panel where that lower rub rail goes. This does not include the terminals or anything beyond that transition zone, but it will include again the post and the connection. Just want to point out this item only applies to the railings on the bridge, not transitions protecting the substructure. If you do have damage down below to this guard railing, we do have that guardrail element 893 you could use that for. Again, this only applies to vehicular railing transitions, and it should be coded, so it's going to be coded N for pedestrian railroad bridges. But if in this case, if there's no approach guardrail at all, you're just going to code this as N. And this was actually a kind of a trick question on their pressure training test. We had that on there. What should this be rated? And of course, it should be N. I think we had about 6% of the people actually provided a rating for it, even though it doesn't exist. And again, this one does not impact inspection intervals. So even if you have some severe conditions on there, it's not going to knock down your required routine inspection interval. So here's a coding example for this one, a rating example for this. In this particular one, the limits of the transition area are not really clearly defined. Like again, we estimate about 20 to 25 feet from the end of the bridge. You could look at your notes for element 893 guardrail, but that rating's probably not going to help you because that's just a one each item, and you don't know if that was rated down for things beyond the range of that transition zone. Here are some close-up photos of this particular transition. This was a bridge that was constructed back in the 60s, but the approach guardrail wasn't installed till 1983. So by then we're using a totally different connection. We were using a 4-bolt connection, whereas the existing railing only had spaces for 2 bolts. But the bolts are in there, they're in good condition. So this is not to this item doesn't rate the adequacy, only the condition. So as long as the bolts are intact, that condition is okay. We got some fading of the galvanized coating here. We also which isn't really considered, but you can see some minor plow scrapes in the plate. But in this case, any significant damage to the plate beam is beyond the transition zone. The other components we want to look at are the posts. In this case, we have at least 2 posts that are totally rotted away within the transition zone. You can see they're pretty well rotted and pretty well non-existent at this point. So here are the coding options for this item. And again, it's we kind of just included the timber stuff on here because that's where we saw the biggest problems with this transition. And so where would you rate this at? And what we thought is this is that as far as the I'm sorry, the decay on these timber posts, you have some choices of moderate, significant, or severe, and we went with severe for this one, which would go with the condition state 3. If you call this significant and rated condition state 4, would have a hard time proving you wrong. But again, that's why your inspection notes are really critical for these new items. So we went with a 3 for this one. Moving on, we've got bearings now have their own component rating. We mentioned that earlier. The initial coding will be a 9 for this one. So you got to, again, have to determine what that coding should be. If you have we have a lot of newer bridges with integral abutments where those bearings are fully encased and closed. In this case, we don't even have a bearing element. If you don't have bearings, you don't have a bearing element, you just code this as an N. Obviously for culverts, you're going to be coding this as N. The Federal Highway does want the condition of hinge bearings, cantilever hinge bearings to be included with this. We do have, at least several hundred, I don't know how many, at least 200 or 300 bridges, I think, in the state that have those. So keeping that in mind, those should be included. We don't consider protective coatings, just if there's corrosion or anything else on those bearings. And again, just like the other ones, this will not impact your inspection intervals for your routine inspections. And here's a rating example for this new bearing component. Elastomeric pads, they're generally easier to maintain than those older rocker bearings or sliding plate bearings, but one issue they do have is a tendency to walk out below the upper plate. Some of the newer ones, we put in some, some restraints around the edge of that upper plate to try to keep those from walking out, but you'll run across this once in a while that pad moves out. And here's the guidance for for the bearing element for condition states 3, 4, and 5. The SNBI has very specific guidance for the loss of bearing area, and we included that in our tables. And so in this case, it's set basically upon that percentage of loss of bearing area. So based on that, since we have some bearings with the loss of 30 to 40%, that correlates with the condition state 4 for that item. It'll be interesting to see how this works if we run across a lot of these. So again, we appreciate feedback from these as you're going out and rating these new items. The joint condition rating is also a new item will become migrated in with a rating of 9. One thing about this is that the SNBI, they do not want to consider the condition of poor joints that are not designed to accommodate expansion or contraction. And the vast majority of the poor joints on our bridge decks are not really designed. They're more like maybe a saw and seal joint, maybe along a center line or an end block, things like that. So a lot of our joints are not going to be considered in that if they're just that type of a saw and seal joint. Also, this does not include approach relief joints. It only includes joints that are actually on the bridge deck or right at the end of the, right where the bridge deck ends. And we have in our rating system, we kind of set this up so it would identify joints that are leaking. So if you have leakage issue, this item will be rated either 5, 3, or 1. So it kind of cuts down your rating options for those. But we really wanted to specifically identify joints that were leaking. So here's a rating example. This is a strip seal expansion joint. In this case, it's kind of opened up, so it's nearly at the design limits. However, the gland is pulled tight, but it's still seated in extrusion. It hasn't pulled out at all. And the joint is not leaking. So looking at the table here, and this is on page B16, we can see that since it's not leaking, we don't want to go with a 1, 3, or 4. So I only showed 2, 4, or 6. So what would be the best one for that? Now, again, the gland is pulled tight, but it hasn't pulled enough that it's actually pulled apart. So we were thinking of these, probably the best option would be that the gaps are near the design limits. So that would lead to a condition state 4 rating for that joint. Now moving on, the channel item, we still have this, but there are now 3 waterway items that we have to rate in addition to the channel. We'll get to those after we do this one. Anyway, this one should migrate directly and accurately from the old item. If the conditions haven't changed and your old rating was accurate, you shouldn't have to adjust it much. And those channel notes will carry over if you had any channel notes. Like before, this rating considers the condition of the channel right at the bridge, below the bridge, but as well as upstream and downstream of the bridge. Generally, we say, as far as you can see, as far as visible from the bridge, you want to consider that in your rating. One thing we've had added to the table is some guidance that's right out of the SNBI regarding the angle at which the channel hits the substructure. We've had some mixed feedback on this so far. Some people like this, some people do not like it. They think it's going to make the ratings harder and more and maybe more inaccurate. So, we again appreciate feedback and opinions on this. So we'll see if we keep that in there or not. But again, we had some mixed reactions on that new guidance. Oh, I just want to point out this item does impact routine and underwater inspection intervals. So if it does drop down, I think bridges must be 5 or higher for a 24-month routine interval, and culverts must be 6 or higher for a 48-month inspection interval. So here's our rating example. This is another one that we was right out of the refresher training. The table that's right in the SNBI for this item was kind of sparse, so we tried to add some more guidance, but the language is still pretty subjective, and it's hard to say, and there are a lot of things in there, and it's hard to say sometimes which guidance should govern. But you know, we are going to, you know, we do appreciate feedback. We might be revising our table in the future. So looking at this, you know, it's going to be based on very generic terms like moderate, significant, severe. So, you know, different inspectors might look at this and give a different rating for how severe they think that bank erosion is. Um, so again, there's our table there. Now, based solely on this, you know, we also added this statement that assume that the bridge and approach are not threatened. And so that's something we can use in the coding. So that might lead you towards a slightly higher rating than if you just base it solely on the on that. Um, so in this case, we did go with a 5 for this one. And you know, I think about 80%, 88%, I think of inspectors came up with that same rating, but everyone, all 100% of the people, I think, were within that plus or minus tolerance of 1. So even though these tables are a little bit subjective, with that tolerance, we get really close on those. Moving on, there are now 2 additional changes. One of those channel ratings for channels, and one of those is this channel protection item that they want the protection rated separately from the channel. So obviously there is going to be some overlap between this item and the channel item. There's also going to be overlap between this and the MnDOT slope element. This will come in migrated as a 9 or an N. But for the most part, this item should include any sort of channel or slope protection located at or below what you consider to be the high water elevation for that bridge. So wherever that, you know, that highest flood level would get, any protection within that area should be rated under this item. Again, there'll be no notes coming in for that. A lot of times we don't have a lot of very good notes for the channel anyway. So it's really important for you to get out there and, you know, provide at least, you know, describe the type of channel or slope protection that's present. It's a good idea that, you know, it's something you can compare to see what's shown in the original plans. For culverts, you keep in mind for this item, they must be rated 6 or higher to keep that 48-month inspection interval. So if you do rate this down, you might lose that 48-month cycle. You might go back to the 24, the 2-year cycle for those culverts. So here's kind of an example here. This is a bridge that's about 20 years old. The plans show the high water elevation even at the top of the slope. So all this riprap should be considered in the rating of this item. All the riprap appears to be in place, but in some locations here, you can see where that riprap has settled maybe slightly from where it originally was placed. You can see from where the special surface treatment was put on initially when that bridge was first constructed. So looking at the condition ratings here, we just included condition states 5, 6, 7, and 8. You know, and so looking at this, you know, we do have some settlement here. Would you call that settlement minor, inherent, moderate, you know, minor to moderate? Again, rather subjective terms, but in this case, we felt this was that minor was probably the best way to describe it. So we went with the condition state 7 for this one. And the final new SNBI condition item that we have to rate during routine inspections is the scour item. This must be rated for all bridges over water. This includes culverts. The old item, we used to have an old scour item that didn't include culverts, but you do have to rate it for all culvert structures. Again, element 885 scour is no longer being used. We haven't deleted it from all the reports. It's still in there. So the notes should hopefully migrate that over. But once you rate this new item, you can go ahead and delete element 885 from your inspection report. We'll probably have to go through after the next round of inspections and start deleting that one out. But that one will eventually disappear as soon as we get that deleted, either from the inspectors or from our unit doing it. Keep in mind that for this item, a rating of 3 will impact both routine and underwater inspection intervals. So if it does get really bad, that will knock those down. And also keep in mind that all three of these waterway items have been, if you've had a bridge, if your bridge has had an underwater inspection within the last year, because we started actually last year at this time, rating these three items as part of those underwater inspections. So these items might already have been rated for you. So you're just gonna have to kind of look at them and see if anything's changed since that last rating. I probably wouldn't change the scour rating from what the underwater inspection says unless conditions have really worsened or scour counters maybe have been installed to correct a problem. So here's a rating example for the culvert item. Here we got a bridge with two piers in the water. It's on, this bridge is on the statewide underwater inspection contract, and past underwater inspections have found no scour or footing exposure on the bridge for those two piers. Now in this case, you can see here the abutment footing is kind of exposed, but this is well above the design high water elevation and is related to settlement of the embankment and not really related to scour. So you probably shouldn't consider that in this rating. So here's some condition ratings from the table from P19. Here we included condition states 5 up through 8. And keep in mind the rating cannot be left at 9. You do have to rate that lower. Now in this case, we went with a condition state 8 due to in this case, there really wasn't anything observed scour that would constitute rating it lower than that. In this case, again, what we saw up there in the abutment was really not due to that, so we took that out. Bridge scour, the way it's defined, it's the erosion of stream bed material or bank material around piers and abutments due to flowing water. If you're being really picky, you could almost argue that no bridge over water should be coded as 8, no scour, because you might have a little bit, but again, we felt in this case it was so negligible that we left it at a condition state 8. Now, before we move on to some other items, I just want to summarize the impact of these SNBI component ratings on other items. In Minnesota, we've always considered an MBI deck, super, sub, or culvert item rated as condition 2 to be a critical finding. The MBIS has now made this kind of official, but they've also included a couple of these couple new items. They've included the scour and the NSTM or fracture critical item also. So you could conceivably have a critical finding on some other component, but these are the only ones that we're going to query and will officially, will automatically consider that to be a critical finding if you have any of these items rated 2 or less. They did make the NSTM item 3 or less for some reason. I'm not sure quite why they did that one, but maybe they felt that was more important. But that's 3 is considered to be serious condition, but for NSTM, they consider a serious NSTM problem to be a critical finding. For 12-month inspection cycles, we've always required a 12-month inspection cycle if an MBI rating was rated 4 or less. The MBIS did not tie inspection intervals to condition until the last revision that they just did here. But they did create now rules for this. They actually have a slightly different one. They say that anything that's 3 or less, but we decided to keep our stricter requirement of condition state 4 or less. We still have a requirement for a 12-month inspection interval for NSTM bridges, regardless of condition. The new item that comes through with the MBIS is that scour item we mentioned earlier. If that one is related 3 or less, that will force a 12-month inspection interval. And then the other one is the 24 and 48 month. We have, for a 48 month inspection for culverts, we need these items have to be, the culvert has to be rated 6 or higher, channel has to be 6 or higher, and channel protection needs to be 6 or higher. And also the scour item. So if you do have any of those items, if they drop, you're going to lose that 48-month cycle that you have for culverts. We do, in our state, we do limit this to culvert structures only can qualify for that 48-month. and that's kind of in our state statute, so we can't include other structures at this point until we revise our state statute. And the other thing I want to point out is that that channel protection item of 5 or less, that's only going to apply to MBIS structures. So if you have smaller culverts in that 10 to 20 range, that won't impact that 48-month cycle. I just want to talk briefly about the new appraisal ratings. These are ratings that we do want you to review during your next inspection cycle. Once they're reviewed and rated, they should rarely change. The first one is the approach appraisal rating. This replaces the old MBI item 70. It has a simple good, fair, poor rating instead of the old 0 to 9 scale. We will migrate a rating, a good, fair, poor, based on that 0 to 9 scale, but it's only going to be as accurate as the old rating was. This only applies to vehicular roadways and only applies to the roadway above a bridge or culvert. So if you have a pedestrian or railroad bridge, that's going to be coded as N, and it's going to be based again on site distance alignment issues that result in a speed reduction for that bridge. And then the other appraisal rating is called overtyping likelihood. This replaces old item 71, which was waterway adequacy. This one, they changed it around quite a bit. They went to a 0 to 6 rating instead of the old 0 through 9 rating. They also flipped the scale around. So instead of like all the other items, this one 6 is the worst condition instead of being the best. Again, we will migrate a rating for this. Again, but it might need adjustment. This rating used to include a few different things besides the roadway classification, the potential traffic delays. Now it's based solely on just the frequency of overtopping. This is a hard item to rate if you don't know the flooding history, but we do want you to give a stab at it and try to do your rate as best you can. We are hoping to have this item coded as part of the initial hydraulic data on new bridge plans. So in the future, we wouldn't have to change this unless there was somehow a big change to the waterway that was causing it to overtop more often. And then moving on, in addition to the component and appraisal ratings, we also need to code 2 roadside hardware items during our inspections. The old NB item 36, if you remember that one, 36A, B, C, and D, it had 4 parts: railing, guardrail transitions, guardrail, and guardrail terminations. And those each had just 3 coding items that were meet standards, does not meet standards, or not required. With the new SNBI, there are only 2 items to code, the bridge railings and the bridge transitions, which would seem simple, except for each of these 2 items have about 25 coding items, 25 coding options. The Federal Highway wants a specific crash test design standard and crash test level. Unfortunately, of course, in the SNBI, they provided no specific coding guidance for these items. So each state must develop kind of their own coding system for these 2 items. This is ours. We kind of this is what we handed out at the seminars. We also have this in our BSIPM Chapter D. I imagine we'll probably be revising this a bit in the next 2 years as we get feedback and get new stuff in there, but this is what we have for now. So you'll use this one to code these 2 items. Bridge railings, we narrowed down the coding options from 25 down to 11, and those are on page 42 of this SNBI, what we call the report entry guide. This item will be displayed on the routine inspection report entry form. But for now, inspectors cannot enter this code directly for bridges. You can for culverts, but not bridges. So what we're going to do initially is we're going to code this item based on the MnDOT rail type code. And so what we want inspectors to do in the next couple of years is to verify the type of rail type that you have present on your bridge and make sure that coding is correct. And we'll go over that a little bit here. The coding item, this is displayed on your inventory report. It's also in pages 11 to 41 of this entry guide. We've been using a numerical code to identify the left and right rail codes since the 70s. This has never been a federal item, so we've never really emphasized it much as a compliance item. So those codes are not always 100% accurate. One thing we have added this year, in the past, we just had a left and right. We've now added a new one for median. It might not impact you. You might not have a lot of bridges with a median, but if you do have a median, we now have a new item so you can code what type of barrier is present on that median. Um, Pedestrian, keep in mind that this is only for vehicular railings. We don't code the type of pedestrian railing they have out there. So again, only for vehicular bridges, vehicular railings, not for railroads or pedestrian bridges. And in our manual here, we have our rail type codes are listed in two tables. The first is a smaller 2-page table that just lists the rail types by the code number. They're arranged just by the coding number. These numbers were assigned as new rail types were introduced or discovered. So they really came on board chronologically. So they're not grouped by any particular type or material. So it's kind of hard to find them. They're all over the place in there. And for 2025, we've added several new coding type options. We're now up to about 83 options that you can code these rail types. The other table is arranged by material type to try to make it easier for inspectors to identify these in the field. So it's kind of by type and material. This table is going to be much longer, includes all the diagrams and descriptions of these. And they're grouped, some of the grouping types are, we have some new guardrail ones. We have a single slope concrete barriers, which are kind of the new design. We have the slightly older GJF concrete shaped barriers. We also have concrete parapet railings that have, like, say, a combination type railing. You can see there in the upper right-hand corner. We also have the older one-line railings, like in the bottom left-hand corner there. We also have metal railings and timber railings. So they're all kind of grouped by that. So when you see what type of railing you're on there, you can hopefully find better what that code should be for that. We have revised many of these railing diagrams and descriptions. We've added kind of the range of years that each type was typically used in this state, so to help you kind of identify those. It'll also identify what crash test level that railing should be coded as. Again, we'll be doing that automatically based on this coding, but at least it'll explain what that code is for each rail type that you go in there. So if you have, for instance, this is a code 42 railing, we would code that in as I not crash tested for that new roadside hardware item. I'm using our timber rail types example why our rail coding could be inconsistent. We have over 700 bridges in the state with timber railings, and we have 7 different rail type codes. The numerical order is kind of all over the place because these were added in through the years as these new types were found. Some of these railings will meet like the older NCHRP 350 crash standards. Some will meet the 1964 AASHTO strength requirements, and some will not meet any standard at all. We kind of grouped them in the manual from new to old based on common years of usage. But anyway, for example, of glulam rail beams, that's code 50. They came into use in the mid 70s. We have a lot of bridges coded as code 6, which is a sawn timber beam that probably should be coded as 50. The plans will identify those glulam railings in the field. You should also maybe be able to tell the difference between a glulam or a solid sawn timber beam, like you see here. I mean, this is a glulam in the photo. For newer ones, one thing you can look at if you want to identify these is the curb connection detail. When you see the type like here with the has 2 curb bolts on each side of the post, that's typically enough. It will typically tell you that's a TL2 design. And if you see three bolts on each side of that, 3 curb bolts on each side, that's typically a TL4 design. The newest types, code 71 and 72, have a 4-foot horizontal rod anchored into the timber slab. There'll be 2 of these at each rail post. You can see these obviously more in the plan, but if you look at the exterior, you'll see the kind of the where those at least the top of those were anchored in each side of the post. So that's one way you can identify those newer 71 or 72 types. Even with all these 80 plus rail type codes inspectors, you're going to come across a lot of railings that don't match any specific diagram that we have in this manual. We do have some general codes for those. And one thing, we used to have some old MnDOT codes. One was code 01 that said meet standards for high speed, and 02 was meet standards for low speeds. We've had to eliminate those because they really didn't provide a crash standard. They didn't specify material or configuration, so we really couldn't migrate them. So we've kind of developed some new general codes, and all those have been migrated to this code UN, which is unknown. So if your bridge on your inventory sheet, if you see a code UN, you need to select another code. The first thing you want to do is check the rail type diagrams to see if if it does match what you have there. If it does, enter that code in there for that particular railing. Um, Another thing you could do is you could look at the plans. You could see if that on the plans, if that railing does meet some sort of a crash test code. If it does, and maybe on newer bridges, you might say right on there it meets MASH TL2 or something like that. We do have some general codes you could use there to code those. But for a lot of bridges, and this is probably going to be the majority of the one you're going to see, they're not going to match anything in our manual. They're not going to meet any sort of crash test thing for you. You might not even have plans. So what we're going to see is a lot of these are going to have to be coded as type 00 in our system. And with those will correlate with, I think, code I for that new roadside hardware item. But I think that'll be a popular code, that 00. Also, a great idea to make sure you have photos of your railing entered in SIMS. That'll help us. If we have a question on it, we can see that photo and maybe code it for you. Here's a rail type coding example. This is a bridge that was, I forget how, this built probably about 15 years ago, 20 years ago. It has concrete F barrier with what we call a steel structural tube mounted that's mounted on the exterior of that. This particular type actually has two steel cables that run through that upper steel railing. It kind of adds some additional strength to it. This was not a rail type code that we had in our system until recently. The rail type codes for GJF type barriers like this are on pages 21 to 24. We've recently added in this rail type code 73 that describes this particular one. And again, we probably don't have hardly any bridges coded with this since this is a new rail type, but if you happen to have this present out there, that's the code you would use for that rail type. And then the other SNBI item that we need to look at is this BRH02 transitions. We have guidance for that on pages 42 to 46 of the coding guide. This replaces an older item, the MBI 36, but the code, there's no way for us to migrate that coding because it didn't give us enough detail in that old coding system. Also, we don't really have a transition type item like we do for railing, so inspectors are going to have to code this item directly. We will bring in notes from both items 36B and 36C. So if you did have any notes describing, why your transition was coded or what was coded, those will migrate over, and you can use that information to help you code this item. There's none of us are really guardrail experts in our office. So what we did is we took this manual. This is called the MnDOT Roadside Hardware Identification and Inspection Handbook. It offers a lot of guidance in there. We just basically took that and put that right into our manual, the information they had in there for guardrail transitions. Anyway, like I said, in the SNBI, there are about 25 coding options for these. We've narrowed it down to just 5 codes that you should be using. There are 3 temporary codes in yellow, but those are going to disappear soon. So if you have any of those ones that you see down those yellow codes, you're going to need to recode those using one of the 5 codes above. Again, this only applies to the roadway going over the bridge, not under the bridge. So you're, again, only using that. We're only coding the adequacy of the one above the bridge. There are a couple different things you'll run across. First off, you'll come out to a bridge and you'll have a no approach guardrail. So for that, it can only be one of 2 codes. So it's either going to be coded as required but not present or not required. To code that, to determine that, you first need to determine, well, is guardrail required or not? We have some tables in there and guidance in there and in this system based on roadway speed, ADT, and deck width. If you've ever coded old item 36, you should be familiar with those, and you should have existing notes. Like I said, you could migrate over and use. So here's kind of a coding example of a bridge. This is on a township road constructed recently, about 2013. It's about 55 miles speed limit, so high speed, but low ADT. And the deck width is 28 and the approach roadway width is the same. So based on this, the criteria is on page 43. That's based on our Minnesota rule 8820. And in this case, you must meet both of these bullet points in order for that bridge to require approach guardrail. So in this case, the speed is over 44 miles an hour. It's 55, so it meets the first criteria. However, the second criteria, it doesn't really meet either of those. The ADT is less than 400, and the deck width is the same width as approach roadway. So in this case, approach guardrail would not be required. So the way we would code this one would be as N not applicable for that BRH02. Now the other, if approach guardrail is present, there are three coding options. There's a MASH option, there's an NCHRP, or there's does not meet standards, or does not crash tested. As far as MASH guardrail, the guidance is on page 44. It should be pretty easy to identify these. For one thing, they're only going to be fairly new, installed from 2016 or later, typically. They're going to have what they call a thry beam, which is that deeper plate beam that you see there in that top photo. Also, it's going to have steel guardrail posts. So if it meets those things and the other criteria on page 44, you'll code that as M163 if all those details check out. The other more common guardrail type we'll see, especially on the local system, will be this NCRHP 350. Those are outlined on pages 45 and 46. So you'll code these and there's requirements in there for size of the end posts. You're going to need like a curb transition or rub rail below the plate beam. And if it does meet all those details on one of those two pages, you'll code this as 3503. The 350 is for the NCRHP 350, and the 3 is for crash level 3, which is what we design most guardrail to. And then the other option is for anything else that doesn't meet those, you're going to code it as I, not crash tested. It can be kind of tricky sometimes to verify if a guardrail transition meets the NCRHP 350 or MASH requirements, but it should be really easy and quick for an inspector to identify transitions that do not meet these standards. For instance, none of these have the thry beam plate, so none of them meet the MASH standards. None of these have a concrete end post large enough to meet NCRHP 350. If you look at these, none of these have a curb or rub rail below the plate beam, so they're not going to meet NCRHP 350. If you look at some of these, like this one here, the guardrail is not even connected to the end post, so that's not going to meet it. This one down here at the bottom left, that has an older 2-bolt connection, a small end post, that's not going to meet NCRHP 350. This one here has a 4-bolt connection, but instead of being connected to a concrete end post, it's connected to a steel plate that's bolted to the railing. So again, none of these are going to meet any of those two other standards that we talked about earlier. So all these transitions will be coded as I, not crash tested. Here's another coding example for whether or not this one what this should be coded. Here we see some plate beam approach guardrail. It has timber posts. And looking at this, first off, does it meet MASH standards? Well, it doesn't have thry beam. It doesn't have steel posts, so it does not meet none of those things. So it does not meet MASH. So we can rule that one out. So it doesn't meet NCRHP 350. Well, it has a plate beam. It has timber posts, but there are a couple of things. First off, the end post is too small in this bridge. so it doesn't meet the end post requirements. Also, there's no rub rail or curb rail coming into this one, so again, does not meet NCRP 350. So in this case, we're going to be coding that one as I, not crash tested. And so just because we code it as I, there's no obligation to upgrade that to a thing. It's, this is just the way we want it coded. It's not unless you were doing some sort of a roadway project that was using, say, federal or state aid funds, that at that point you might want to have that guardrail upgraded to the current standards. So, just that it's out there, you don't have to upgrade it automatically. Now, this is where those railing and coating transition type items are entered into SIMS in that report. In this case, this one has a transition code that you can see there, a temporary code 10T for the transition. So in this case, you're going to have to select one of those other options depending on what you have there, either N not applicable or I present not crash tested, 0 not required. So you'll have to pick one of those upper codes for that item. If any of you have started to do some entries in SIMS, you might have realized that we have this, what we call now the bar that has to go through, and maybe you've got some error messages back. One error message we are getting is this one right here. It says BC06 has a rating value, but BRH02 is coded N. This occurs when the inspector has rated the conditions of the transitions, that's BC06, but item BRH02 is coded to indicate there are no transitions. So one of those has to be incorrect, but we don't really know which one. Could be one or the other. Here's a first example where we got this coding message back. This was an overpass bridge that has long approaches with retaining walls, and the bridge and approach have the same, and the retaining walls have the same railing, so it's kind of continuous across there and it continues quite a ways down on that long retaining wall. And in this case, the inspector rated that transition condition for BC06. Now looking at this one, where those terminate though, in this case, you can see there's no approach guardrail where that railing terminates. In this case, it's a city street with a speed limit of 35 miles an hour. And actually, with those wide sidewalks, approach guardrail is not required for this bridge. And that's why it was never installed. So in this case, you can see here where it was never installed in this. I don't know why they have the holes there for it, but they were installed. So in this case, for this one, to eliminate that error, that you should not be rating the transitions on this bridge. There are no guardrail transitions. So that should be the way to eliminate that error, just by changing that BC06 from whatever they rated it, maybe it was a 7 or an 8, to N. Now here's another case, another bridge that had the same exact error, but it was kind of the opposite situation. In this case, this was a kind of an interesting, unique situation. This was a case where a bridge had railings and a narrow sidewalk, and then what they did is they came in many years after the bridge was constructed. They built a new retrofit barrier between the roadway and the sidewalk. So and at the end of that barrier, to protect it, they installed these crash cushions. So in this case, the inspector had rated that the BR2, they had rated the condition of these transitions, but that item B, the roadside hardware B or HO2, was coded as N. A crash cushion basically serves the same purpose as an approach guardrail. And in this case, since approach guardrail exists, you should be, coding it as to what it should meet. In this case, we don't, in our manual, unfortunately, we haven't added in the examples for coding these crash cushions. That is available in that roadside hardware identification hardware manual I mentioned earlier. But in there, they show this specific kind. I think it's called a Tau M crash cushion, and this does meet MASH TL3. So by changing that BROH to meeting that standards, that would eliminate that error. If you do have a crash cushion run across one of these, you can let us know. You can maybe send us a photo of it. We can help you determine what the coding of that crash cushion should be. It's pretty rare. We don't see these in a lot of bridges, but in this case, we have it there. So I don't know, that was a lot to cover, and I apologize for that. So it's kind of a long thing, but if you do have any questions now, I could definitely try to answer. I don't know if any of that doesn't sound like we have too many, but again, we appreciate it. As you get out there and kind of use these manuals, we appreciate any feedback we can get to try to improve them. But I know we're going to make some revisions. We're already kind of looking at the next couple of years, but we'll put the next field manual up probably in 2 years from now. So, but any feedback we can get, we really appreciate. And other than that, if you do have any questions on how you should be rating some of these items, um, please let us know. We're happy to help you out and try to clear up some coding problems. I'm sure we're going to have a lot of issues, especially with this new bar check in Sims. We're getting some, it's a good way for us to also to correct some problems and find some issues that we need to maybe provide better guidance for.